Hello, and welcome to the second tutorial in our Massive Loop SDK tutorial series. Previously, we showed you how to install, set up the Massive Loop SDK, and upload a simple world to the metaverse. In this tutorial, we'll cover what Unity features you can use to construct your world or game without any Lua programming. To illustrate this, we will use this world to demonstrate those Unity features. It's worth noting that not all of Unity's components and features will be shown here, but most of the common features will be highlighted to illustrate how Massive Loop leverages the Unity engine. The SDK is expanding all of the time, so if there are any questions about which Unity components will work, consider joining the Massive Loop Discord and asking in the developer channels for help. The Unity Shuriken particle system can be used to achieve various effects in the world. These effects can range from atmospheric effects such as fog, dust, or to more complex visual effects like fire or water. The audio source component is used to play audio files within your scene. You can use it to play ambient sounds within a space, or use it to play music in your world or environment. The Unity animation and animator components can be used to add movement to your world. These animations can range from simple translational object movement to doing fully realized character actions and gestures. The Unity timeline system can be used to create more advanced sequences, utilizing both audio, animation, and particle systems. This can be used to create sequences that range from playing multiple animations and sound effects, or to large set pieces that take place within your world. The video player component in Unity allows you to play video clips within your world. You can use it to play custom video clips in your project, or have it play a video through a URL link. Physics allows your scene objects to be controlled by physical forces such as gravity. By utilizing physics, you can have dynamic and movable objects in the world. Unity physics also allows you to use joints to create levers, ropes, and cloth. In addition to that, physics materials can also be leveraged to make different kinds of surfaces like bouncy or frictionless surfaces. Render textures are a Unity feature that allow you to render the view from a Unity camera into a texture. This texture can then be used to either create screens within your world or perfect mirrors. Custom shaders can be created to simulate various graphical effects in a game world. The range of visual effects that you can create through shaders is limitless. Keep in mind, before creating or using any shaders, that you check if they are supported in single pass instance VR to avoid any unwanted graphical artifacts when playing. Skyboxes are a rendering feature that wrap around your scene to show what the world looks like beyond the boundaries of your scene. You can use static texture skyboxes or procedural skyboxes either using the built-in shaders or a custom shader. Unity has a very robust and flexible lighting system that can be used to influence the look and feel of your worlds. With Unity's lighting system, you have the option to use either real-time lighting, baked lighting, or mixed lighting. Which lighting style you choose will depend on the world that you intend to create. Real-time lighting means that the lighting is calculated for every frame that is rendered. This means that lighting changes instantaneously to reflect changes within the environment. This can be used to achieve dynamic lighting using flashlights, searchlights, or for more drastic changes like a time of day system. However, this lighting style is the most expensive as lighting is recalculated for every frame that is rendered. If the world you are creating is dynamic and the environment changes often, this would be a valid option. Baked lighting means that lighting is pre-computed before the level is built and is not recalculated during runtime. This means that lighting cannot change and adjust to changes within the world. However, the advantage of baked lighting is that quality is much higher than real-time lighting and it's far less intensive to run. This can be used for worlds where lighting is static and does not change. Mixed lighting is a combination of both real-time and baked lighting. You can get the best of both lighting styles by using mixed lighting, leveraging both high-quality baked light maps and real-time lighting. Post-processing is a collection of graphic effects that can greatly improve the appearance of your world. You can use it to color your worlds, giving them a naturalistic or stylized look. or using bloom to help emphasize bright light sources within your scene. Keep in mind that because Massive Loop is in VR, it's not recommended to use expensive effects like depth of field, motion blur, ambient occlusion, and screen space reflections in order to maintain a high frame rate within your world. In addition to that, custom post-processing effects won't be supported by the Massive Loop client. Occlusion Calling is an important feature to consider when developing your world for Massive Loop. Since Massive Loop is VR only, and given the high frame rate requirements of VR, it's important to manage the resources of your worlds to maintain a proper frame rate. Occlusion Calling reduces rendering computation by hiding objects that are not visible within the camera view. This is very useful for large scenes that contain lots of objects that are drawn on the screen. That is all the features and components that can be utilized from the Unity engine to help you construct the experience for your Massive Loop world without any programming. In the next tutorial, we will cover our introduction to scripting, which will give you the power you need in order to turn a static world into a dynamic experience or a realized multiplayer game.